Good evening, distinguished students. Welcome to 2024 Section B, Chemistry. This was GCE. So you can type there your comment, how are you doing? You can type your comment, I can get your comments there. How are you all doing? Okay, so we just want to make it quick. We have a live class. So if you're using a tablet, it's okay, it will be visible. If you're using a TV to watch, it will be visible. If you're using a phone, make sure you rotate your phone, you put it on landscape. So how do you rotate? So you put it on landscape like this. So make sure your phone is on landscape as you are watching so that you can have clear view. So make sure as you are watching, you put your phone on landscape. All right. So if you are watching using a phone, I'm saying you make sure that you put your phone on landscape and understand. Can you get me? Okay, so let me open the comment section so that I see if you can get me. All right, Sharon, you're welcome, saying she's good. How are you all doing? Type your comment there. You see if you can get me. Mambwe can get me. Okay. So like I've said, rotate your phone. Address, okay, can get me. Okay, you rotate your phone. Make sure your phone is rotated so that you can have clear images, you can have clear view. So this is how we'll be having the live classes most of the times so that you don't complain network or anything. Okay, Natasha Zambo can get me. Ines can get me. Beatrice, you're very audible. Okay, all right, so we're going to begin. Make sure put your phone on rotation. I want you to have clear image as we'll be learning. Okay, if you're using a phone or a tablet, it's okay. If you're using a phone, you rotate so that you have clear image. The volume is low. Cecilia, make sure your volume, check your volume, check your volume, check your volume, check your volume. Because here it's showing it's just clear. So if you're using a PC, yeah, on a PC it's good. Cecilia saying the volume is low. Okay, here the volume is okay. All right, so let's begin. Okay, here the volume is okay. So question 1, I'm reading your comments. So what you'll be doing, if you are not understanding or you have a question, so you can simply ask, because I'm checking your questions. I'm going to disable here. Then you'll be sending your questions from there. Okay, you can see Deborah CMK. Okay, so what's the first question? So when answering questions in an exam, the first thing that you need to do is to understand what they are asking you. So the question here, it's asking you saying a box of chemicals in a laboratory has the following symbol attached to it. So that's the symbol which has been attached to it, as they are saying there. So what's the question now? The question is saying describe the nature of chemicals in the box related to the symbol. So what's the nature of that box? So what's the nature of the box? Before I even answer, so what we'll do here, because this is a live class, you need to participate. We're not rushing anywhere. You type your comments, then I read them through. I tell you the answer as much as I'll be explaining. Okay. So what do we have here? All right, good evening, Christabel. So the question is saying, describe the nature of chemicals in the box related to the symbol. So how do you find the nature here? As you can see, how do you check the nature here? So number one, the nature here, look at it properly. This is fire. It contains fire, is it? So it's something which has fire. Now, if it has fire, how do you respond or answer your question like that? Question 2, it is saying, write a laboratory rule that is observed when handling chemicals in this box. So how do you handle chemicals in this box? Okay, I can see Mary saying it is highly flammable. Okay, Teresa saying it is highly flammable too. Now, so when answering, imagine you can't learn this. This is now common or general knowledge. Are you getting that? So don't expect to learn everything. This is general knowledge. So how you answer this, you say, this shows that it is flammable. This shows that it is flammable, or it can easily catch fire, or it is fire itself. So those people that you are writing know it is fire. Since chizungucha flammable, if it's not there, you just write, okay, this shows a feature of fire, or it's something which is what? Flammable. So you say, okay, it's something that is flammable. Here you put, okay, here it is flammable and it can easily catch fire, or it is fire itself. Are you getting that? So that's what you're supposed to do, or to answer this question. Now we go to the next question here. So the next question is asking you to say, write a laboratory rule that is observed when handling chemicals in this box. Number 1, you've seen it is made up of fire, so it must be kept in a cool place which has low temperature, because if this is fire here, meaning it is highly flammable, any mistake, it will catch fire. So you say it should be kept in a cool place. Number 1, you say it should be kept in a cool place, and it should not be what? Should not be exposed to any fire. That's a laboratory rule that you can keep there. So they're just saying 1. So the one there, you just say it should be kept in a cool place which has got low temperature. Should be kept in a cool place which has got low temperature. All right. So that's how you answer that one. Then we go to the second question. So those that are writing, you write answers here. You say low temperature. Okay, those writing answers, low temperature. So you make sure it has low temperature. But make sure, what is it first? We say the cool place. So number 1, you put it in a cool place which has got low temperature. That's how you answer that one. Then, as we proceed going to the next question, it is saying, when a bottle of ammonia is opened, within a few minutes, it smells spread throughout the laboratory. Name the process responsible for the evenly spreading of smell of ammonia solution. So there, according to what we said, the only process here is diffusion. Okay, the only process is diffusion. Why? Diffusion, it is the movement of particles from the region of higher concentration to the region of lower concentration. So the answer here is diffusion. Why? Because once you put the chemicals there of ammonia, we are saying they sprayed at a short time. So the answer here is diffusion. Okay, I'm getting your answers. I'm checking your answers. So ask your questions. Number 2, describe the process responsible for the even spreading of the smell of ammonia. So they want you now to explain what has happened. Describe the process responsible for the even spreading of ammonia. So we're going to say ammonia particles, they moved from a region of higher concentration to the region of lower concentration. Simply, they're asking you what is diffusion, but in terms of ammonia spreading. So you're going to say this is the movement of particles from the region of higher concentration to a region of what? Lower concentration. If you're typing, you just say it involves the what? The movement here. So you just say, okay, this is the movement of particles from the region, okay, from the region of high concentration to the region of what? lower concentration, then you just put it there. That's what they mean when they ask that. So here you describe it was just a mark. Okay. Then another question, it is asking us to say, the question 2, it is saying relate the evidence which the process named in B provides to the kinetic theory of matter. Relate the evidence. So we said, what evidence tells you that matter is made up of tiny particles? Okay, so this one you can attempt because I'm reading your comments now. Relate the evidence which the process named in B provides to the kinetic theory of matter. It's a mark also. What does it mean when they say relate? So this, they're asking you the evidence that matter is made up of tiny particles. How do you attempt this? Which evidence shows that matter is made up of tiny particles? We have two evidences that you need to understand. Number one, the evidence first is diffusion. Okay, so evidence number one is diffusion. Evidence number two, it is Brownian motion. But according to this point, they are saying relate. So how do you answer that question now? So how to relate? You're going to say number one, particles of matter are in constant motion. That's all. Because diffusion, it is the movement of particles from the region of higher concentration to a region of lower concentration. And kinetic theory of matter states that matter is made up of tiny particles that are in random continuous motion. Particles of matter are in constant motion, that are in random continuous motion. So how do you relate? You say particles of matter are in constant motion. So the particles of matter, particles of matter are in constant what? Are in constant, particles of matter are in constant motion. This is how you answer this question. Are you getting that? So particles of matter are in constant motion. Okay. All right. So this is good to those that are attempting. This is good. This is good. Reading your comments. Keep it up. Okay. So we proceed. We go to question 2. This is how you answer question 1. Now, question 2, it was about the separation technique. So question 2 was about the separation technique. Okay. So the following diagram shows a piece of apparatus used in the lab. So when answering questions, you take your time. Okay. So the following diagram shows a piece of apparatus used in the lab. We have a stopper here, and this is a tap. So this apparatus here, it is called a separating funnel. How does a separating funnel work? So number one, a separating funnel, it is made up of a stopper and a tap, but the liquid which is found here, it is called immiscible liquid. So what is immiscible liquid? Immiscible liquid is any liquid which does not mix completely, e.g. water plus oil. When you get water, you mix it with oil, we form what we call immiscible liquids, meaning they do not mix completely. So liquids that do not mix completely are called immiscible liquid. So which one is heavier between water and oil? Which one is denser? So the one that is more denser, it will settle at the bottom here. So meaning if this is water, water is supposed to settle down here. We'll say this is H2, H2O. And on top, what do we have here? Oil. Oil is always on top because it is less dense than what? Than water. So, or oil is on top because it's less dense than water. All right, so now what happens? How do you separate water from oil? There is a tap here. This tap, they open it gently to allow the flow of water. When water reaches at this point, the tap will be closed. Then you just remain with the oil and few levels of water. Are you getting that? So, what are immiscible liquids? These are liquids which do not mix completely. Immiscible liquid, these are liquids which do not mix completely. Okay, so let's answer the question now. Name the piece of apparatus shown in the diagram. So what's the piece of apparatus? According to the explanation, we said the piece of apparatus here, it is called a separating funnel. So the piece of apparatus is called a separating funnel. Okay, so what do you say here? Say the answer is separating funnel. So this is known as a separating funnel. Okay, yeah. So after answering the separating funnel, the next question is saying, identify one property of a mixture separated by the piece of apparatus. One property of a mixture. So what do you think is the property of the mixture here? So when they say the property, they mean can it be mixed or it cannot be mixed? Is it miscible or it's immiscible? It is immiscible. You say the property, it separates immiscible what? Immiscible liquids. It separates immiscible liquids. What are the immiscible liquids? These are liquids which do not mix completely. Then those that mix completely are called miscible liquids. So examples of immiscible liquids, water and oil. What's the next question? Suggest the names of two liquids that can be separated by the piece of apparatus shown. So two liquids that can be separated here, you say water can be separated. Number two, oil can be separated. Are you getting that? So water can be separated and oil can be separated. So if you're understanding, type your comment there as I'm reading through. I don't want to rush. I want to make sure you understand. So water and oil, these are the liquids that we call immiscible liquids. Okay. Number two, suggest two precautions that need to be taken to separate the mixture in B. What are two precautions that are supposed to be taken when separating the mixer? Okay, I can get you, Eunice. Understanding. All right. Okay. So what are two precautions? Number one, you need to clean the separating funnel. You clean the separating funnel. Clean the funnel. You just say, okay. You clean the funnel. Precautions is what you need to do before you start measuring. So clean the funnel. All right. Number two, it is saying you need to make sure you close the tap before filling in the funnel so that you avoid the water from spilling out, right? So what do? We're saying you close the tap. So close the tap. So you need to make sure you close the tap. So those that are writing answers, that's what you do. Close the tap before. So close the tap before filling in. Close the tap before filling in. So that's what you do. So what were the answers? This was the question. The first thing that you do, they asked us about finding this. We said this is a separating funnel. All right. What property or liquid does it separate? It separates immiscible liquids. What are immiscible liquids? Liquids that do not mix completely. Examples of these liquids, we have oil and water. What are two precautions that are supposed to be taken? You clean the funnel. You make sure the tap is closed before filling in. Okay, and you go to question 3. Just like that. So question 3, it needs your understanding. Question 3 needs your understanding. Okay, so now, what did it say? Question 3 said that the following diagram shows the electronic configuration of ion. Electronic configuration of ion. of an element M. Meaning, I want you to pay attention. What's the difference between an atom and ion? An atom, we say this is a charged. Okay, so an atom, it is a charged. An ion, it is a charged particle, while an atom, it is a neutral. Okay, neutral particle. So now what you do is this. Number one, let's identify the difference between atom and ion. So an atom, it is when it has not lost or it has not gained. It is called an atom. An ion, it is a charged particle formed after gaining or losing of what? Electrons. So the way this is showing from the question that it has lost 2, it is showing 2 here. This 2 plus here, it is showing that it is ion, meaning it has lost 2. Are you getting that? So the 2 that they have put here, meaning it has lost 2, it is an ion. So what's the difference? Atom, it is before losing, before gaining. So what's the electronic configuration of an atom before losing? The first shell it had 1, 2. So the first shell it had 2. The second shell it had 2, 4, 6, 8. The second shell had 8. The third shell had 2, 4, 6, 8. It had 8. Then after losing, it lost how many? This 2 plus, meaning it is the number of electrons it lost, meaning it had 2. This is an atom. This is the complete one, which we call an atom. Okay. Now, when it became an ion, it was after it lost how many electrons in the outermost shell? It lost 2. So meaning the electronic configuration of an ion now after losing, it was now 2, 8, 8. It was stable. It lost 2. So the first one is an atom before losing. The second one is an ion after losing. Okay. Now, the question is saying draw the atomic structure and write the electronic configuration of a neutral atom. So a neutral atom of N, they mean this atom before losing, before gaining. What was the neutral atom? You follow the electronic configuration that you have here first. So this electronic configuration should help you. So what do? We say, we have said that neutral atom of M is equals to 2, 8, 8, 2. This was before losing. So the first shell, it has got how many electrons? It has got 1, 2. The second shell, it has got how many electrons? It has got 8. You're going to say 1, 2, 3, 4, 5, 6, 7, 8. The third shell, it has 8 also. Okay, so we're going to say it has 1, 2, 3, 4, 5, 6, 7, 8. And the fourth shell it has, if you check, the fourth shell it has what? It has 2. So we're going to say, okay, and this fourth one, it has 2. 1, 2. This is the electronic configuration. Are you getting that? So this is the electronic configuration that you needed to draw, or that is supposed to be drawn here. This is the neutral atom, electronic configuration of a neutral atom. So it was 2 marks. Number 1, atomic structure. Number 2, electronic configuration. So you don't just answer one. You first write the electronic configuration, which is this that you have written here. And you write what? Secondly, you write the structure that you're supposed to write. So this is what you are supposed to do when answering this question. All right. Number 1, you draw the structure. Number 2, you write the electronic configuration. So let's proceed. Give the name, group, and period of the element M. So this element M here, how do you check for it on the periodic table? So you check for the element number 1. The group number it is determined by the number of electrons in the outermost shell. So element M, it had 2, 8, okay, so it had 2, 8, 2, 8, 8, and 2. The last shell electron, it tells you the group number. So if you have 2 electrons in the outermost shell, meaning it is coming from group 2 of the periodic table. If you have 3 electrons in the outermost shell, ukukulastinga kuli 3, meaning it is coming from group 3. So how do you determine the name first? The group and period. So it is first coming from group 2. Why? The number of electrons in the outermost shell, it shows you the group number. So there are 2 electrons in the outermost shell, meaning it is coming from group 2. 2 electrons in the outermost shell, meaning it is coming from group 2. Are you getting that? Yes. Then, how do you find the period? You find the period number by checking the number of what? Shells. So you find the period number by checking the number of shells. So let's count. How many shells do we have? You first count shell number 1, shell number 2, shell number 3, and shell number 4. This is what determines the period number. So the period number is determined by the number of shells. So it is coming from period what? Period 4. Why? Because it has got 4 shells. 1 shell, 2 shell, 3 shell, 4 shell. Meaning this guy here, it is coming from period 4. Because the period number is determined by the number of shells. Then what is the name? You check on the periodic table. To find the name here, you add all these electrons. So if you add 2, you add 8, 2 plus 8, 10, plus 8, 18, plus 2, 20. So you go on the periodic table. Which element has got the number down of 20 like this on the periodic table? Which element has got 20 down? You'll find that that element is called what? Calcium. Okay, that element is known as calcium. So this is what you find. So name calcium, group 2, period is coming from period 4. This is how you are supposed to answer this question. Now, compare the reactivity of an atom M and ion M. We go back to our talk here. So the reason why an atom loses or gains is for it to be stable. Why is it that atoms, they lose or they gain? Is for them to be what? Stable. So atoms, they'll always lose, they'll always gain it in order for them to be stable. And stability is determined by them having at least 8 electrons in the outermost shell. The rule is called octet rule. So this guy, the first one here, atom, it was not stable because it had 2 electrons in the outermost shell. For it to be stable, what was supposed to happen? It was supposed to lose 2 electrons. Then once it lost 2, it remained 8 here, meaning ion, it is stable. This is stable. This atom is not what? Stable. So therefore, how do you conclude to answer the question? So how do you conclude to answer the question? You're going to say here, the reactivity M, or the ion M, is stable, while the atom M is unstable. So atom M is unstable, while ion M is stable. So which one is going to be more reactive? The one which is stable or the one which is not stable? The one which is not stable, it will be more reactive since it hasn't yet reacted. So we're going to say M, or atom M, is unstable. So atom M is unstable. Okay, so if it is unstable, hence more reactive. Hence more reactive. Okay, so if it is unstable, hence more reactive. Are you getting that? So if it is unstable, more reactive, while ion M is stable. Therefore, if it is stable, it has 8 in the outermost shell. It cannot lose, it cannot gain, meaning M is stable, no or less reaction or less reactive. Okay, so that's what you answer this question. If you want, I can write it here, but you are writing, you just get the answer. We said that. How do you answer this question? M is reactive. Atom M is supposed to be stable. Okay, so that's how you answer that question there. The atom of M, we expect it to be more reactive. Okay, so atom M unstable. Yeah, hence more reactive. Okay, let's go to the next question. Well, you say ion M gets stable, gets reactive or unreactive because it is what? It is stable. So the ion, the other one is reactive, the other one is less reactive because it is stable. That's what you do, or that's how you answer that question there. So compare the reactivity. Atom M unstable, hence more reactive, while ion M stable, less reactive or unreactive. Okay, so we go to the next question, which is question 4. All right, we go to question 4. So what is question 4 asking us? Question 4 is saying, we're finishing very soon. Salts are substances that have many methods of preparations. Salts are substances that have got many methods of what? Preparation. Then the first question is saying, iron 2 chloride can be prepared by reacting substance X and diluting hydrochloric acid. So, which reactant should be in excess? Now, this is simple. We are doing more concept in the group, right? But understand. Iron 2 chloride. Iron 2 chloride. And this is also, you will find it in books. Iron 2 chloride can be prepared by reacting substance X and dilute hydrochloric acid. Okay, now which reactant should be in excess? So, number one, what's reacting? This is prepared after reacting substance X and dilute sulfuric acid. So the one that should be in excess is substance X, not the acid. So acid shouldn't be in excess no matter what you do. So the acid shouldn't be in excess, yet substance X should be in. You don't know the substance yet, but you just know that the acid shouldn't be in excess. Therefore, substance X, since substance X is reacting with what? With acid to give you iron 2 chloride. You can even tell that this substance X, it is made up of iron, for iron 2 chloride to be formed. And this is the hydrochloric acid. So you're going to say substance. Okay, substance X should be in excess. Are you getting that? Substance X should be in excess. Then, why should the named reactant in 1 be in excess? So, the reason why it should be in excess is to ensure that the acid is completely used up. So, to ensure that the acid is completely used up, that's the reason why it's supposed to be in what? In excess. So, if they say explain why it's supposed to be in excess, you say to ensure that the acid, or you say to ensure the acid is completely, so to ensure the acid is completely what? Is completely used. It's completely used up, so it's completely used. That's the reason why it's supposed to be in excess. So it should be in excess to ensure that the acid is completely used. All right. So why should the substance be in excess? To ensure that the acid is completely used. All right. Getting your comments. I'm still getting your comments here. Hope we are still together. So the reason why it should be in excess is to ensure the acid is completely used. So always put it in mind. Even if you don't know, the acid shouldn't be in excess, okay? The acid shouldn't be in excess. Then we go to the next question. Suggest the suitable reactant as substance X. They are simply asking what is the name of substance X. Now, this is simple. Why is it simple? The question said iron to chloride. Nanga iron yashitamu bwanjumu, meaning obvious substance X is iron. Because what has been given here, we said iron to chloride can be prepared by reacting substance X and hydrochloric acid. So if you get hydrochloric acid, HCl, plus substance X, then it will give you iron to chloride. Now, here we have chloride, which is this side. But what we don't have is iron, meaning, of course, one of the reactant here, it will be iron what? Iron 2. Therefore, this will even give you what we call hydrogen gas. So, what is the name of substance X? Iron metal. So, the name of substance X, we say it is iron metal. So, it is iron metal. Okay, iron metal. Then write a balanced chemical equation for the reaction between substance X and dilute sulfuric acid. They want you to write this equation that we wrote here. So the reaction between substance X and dilute sulfuric acid, and it should be balanced. So how do you balance and how do you write the chemical equation? Okay, so we start again. We say the metal ion reacts with hydrochloric acid to give you always the metal replaces hydrogen ion to produce metal chloride, which is iron chloride plus we have hydrogen gas. So how do you balance? When balancing, you check the atoms are equal. So what products do we have and what reactants do we have? This side we have iron, even here we have iron. Here we have chloride, here we have chloride, hydrogen, hydrogen. So it should be balanced. So when balancing, you check this side hydrogen we have 2, this side hydrogen we have 1. So when balancing, you always put the number in front of that element, okay? You always put it in front of that element. So what do you do now? We put a 2 in front, meaning this 2, it is going to affect, hydrogen is going to be 2 and chlorine is going to be 2. So hydrogen is now 2 and this side hydrogen is 2. So this 2 is also for chlorine, meaning chlorine has become 2. This side chlorine, it has a 2 already. Are you getting that? Then iron here is 1. Iron here is 1, meaning the equation is now balanced after putting the 2 in front here. So the 2 that we have put in front, it has helped us to balance the equation. So how do you balance this equation? We say by just putting the 2 in front here, that has helped us to balance the equation. So this is a balanced chemical equation. That's how you're supposed to answer that. You can put it here. You say, okay, iron plus HCl. This is giving you iron chloride, okay, with a 2 plus hydrogen gas. So balancing, we have put a 2 here, which has made it to be what? To be balanced, okay? Then we go to question 5. Now, question 5 is more concept. So we are doing more concept and they'll always bring more concept questions in an exam, no matter what. So how do we answer these questions now? The question is saying 10.5 of sodium hydroxide was reacted with dilute sulfuric acid according to the equation. So here you have been given the equation already. This is the equation. Okay. Now, 10 grams of sodium hydroxide. So sodium hydroxide here, this has been given already, the mass, which is 10 grams, then was reacted with dilute sulfuric acid according to the equation. So the first question saying balance the equation, it was just 1 mark. How do you balance? You make sure the atoms are equal. Okay, so when balancing here, we check sodium, we have 1, sodium here, we have 2. So once you see the error, you balance it in advance. So let me zoom it so that you see. So sodium here, we have got 1. This side we have 2. So if we put a 2 in front, this 2 is going to affect everything, right? This 2 is going to affect everything. So what do we do now? Sodium has become 2, oxygen has become 2, plus this 4, oxygen is 6. Then hydrogen is now 2, plus this 2, hydrogen is 4. Okay, then sodium is 2, sodium is 2, sulfur 1, sulfur 1. So what do we do here to make hydrogen 4? So we put another 2 in front. So meaning hydrogen is now 4. This side hydrogen is E2 with another 2 here, hydrogen is 4. Oxygen is 2 plus this 4 here, 6. And this side we have oxygen 2 and this 4 here, 6. So meaning the equation is balanced at this point. So this is how you balance the equation. So that tutorial video that I sent on balancing equation, sit down and erase it properly. So balance the given equation. We have balanced it. Then number 2, use the balanced chemical equation to calculate the mass of sodium sulfate. This is what we call now mass to mass. This is what we call mass to mass. So how do you know it is mass to mass? What have you been given from the question? 10 grams of sodium hydroxide. And what is the question asking you? Calculate the what? The mass of sodium sulfate. So they want the mass of sodium sulfate. So what are the principles of mass to mass calculations? This is more concept. The video that I sent you, mass to mass, more to mass, more to more. So you first check what you have been given. So number 1, according to the balanced chemical equation, we have been given the mass of sodium chloride from the question, sodium hydroxide, I mean here. So we'll put it here, we'll place it here, we'll say we have been given sodium hydroxide. It is equating with what? What are they asking you? The mass of sodium sulfate. So the mass of sodium sulfate. So you say they're asking us to find, or it is equating with sodium sulfate, SO4, like this, sodium sulfate. And the question said use the balanced chemical equation, meaning how was sodium when it was balanced? Sodium hydroxide. So sodium hydroxide, after balancing, it had a 2 here. Hydroxide, it was like this. So you first find their masses. What's the mass of sodium hydroxide here? What's the mass of sodium hydroxide? So how do you find? You say 2, number 1, NaOH. Okay. So you can ask questions as we are concluding. So here you say the 2 that is in front, it represents everything here. So this is going to be 2 times 1. Okay, for this point. Then oxygen, because of the 2 in front, it is 2 times the mass number of oxygen, 16. Okay, then we go to sodium. Sodium is 2 times the mass number, 23. So what do we find the total here? 1, 16 times 2, 32. And here we have 23 times 2, we have 46. So we need to add them now. 46, 32. So meaning we have what we call 78. We have at the end, what do we have? So you calculate them properly. This is 6, 8, and this is 7. So you find 88, right? So the mass is 88 according to the balanced. So this is 88. If I'm mistaken, you tell me. I don't have a calculator now. All right, so me, I found it's 88. I found it's 88. Okay, so the mass I found it's 88 here. Then what about the mass of this? You do the same thing to find the mass of this. You just say, okay, we have been given sodium according to the balanced chemical equation. Sodium what? Sulfate. Then you find. Here we have got 4 times the mass number of oxygen, 16. Here we have got 1 times the mass number, 32. All right, here we have got 2 times 23. What do we find? What do we find here? You get your calculator. You see now, these giant questions I'm facing. What is 16 times 4? I start counting again. So, okay, assuming it's 46 according to me, or 48. You tell me the final answer. Okay. Then, so, okay. Then what about this side? Here we have 32. And here we have 23 times 2. What do we find here? 46. Then we add 8, 9, 10, 11, 12, 13, 14, 15, 16. So 6, 1. Then what do you have here? 4, 8, 9, 10, 11, and 12, 126. So here we have got 126 grams. And this side, 88 grams. Therefore, so I'm just showing you the procedure so that on your own, you can do it and work it out, okay? So here, I'm just showing you what you are supposed to do so that when you're on your own now, you can work it out, solve it, and work it out, okay? So we have found 126. 126. Then you go to the question. Now, what was the question saying? They said 10.5 grams of sodium hydroxide. So what have we been given here? 10.5 grams of sodium hydroxide is equals to what? T to X. We don't know. That's when you cross multiply here now. So it's going to be 88X is equals to 10.5 times 126. 10.5 times 126 over 88, and here over 88. So the final answer that you find, if it will give you 10, if it gives you 5, that's the answer, and that's what you do. So this is very simple. You've seen the reason why we learn those. More to mass for you to understand when it comes to this case, okay? Now, what type of reaction is involved in this equation? The acid reacted with a base, sodium. So the reaction here is neutralization reaction. So we're remaining with few minutes. This is called neutralization reaction. Neutralization reaction. All right. So because acid reacted with a base, the reaction is known as neutralization reaction. And this, which is simple, let's move fast here on the periodic table. So an element A is in group 1 of the periodic table. Another element N is in group 7. Write one property of the compound formed when the element A and N react. So group 1 and group 7, when they react, what happens? One property is that they form the ionic compound. And these ionic compounds, they have got high melting and boiling point. So give one property of the compound formed. It's going to have high melting and boiling point. So high melting and boiling point. So one property is that it has got high melting and boiling point. Then what type of bonding exists in the compound formed when the two elements react? This is very simple. Ionic bonding. What is the other name of ionic bonding? Electrovalent bonding. Ionic bonding is also known as electrovalent. So ionic bonding is also called electrovalent bonding. How does the reactivity of the elements in group 1 differ from that element in group 7? So elements in group 1, their reactivity increases as you go down the group. So group 1 elements, they become more reactive as you go down the group. While group 7 elements, they become more reactive as you go up the group, right? So when it's simple, you answer it fast, you move to the next question. So we said group 1 elements, they become more reactive as you go down the group. So you check the periodic table. Then group 7, they become more reactive as you go up the group. All right. So this is what you're supposed to answer this question. And you go to the next question. Metallic bonding accounts for most of the physical properties of metals. With reference to metallic bonding, explain why most metals have got high melting point. So the reason why some metals that have got high melting point, you need to say this. So we said metallic bonding, it is the attraction of the free moving electron and the positively charged ion called the cation. Are you getting that? So the electrostate force or the electrostatic force of attraction between the positively charged ions and the negatively charged ions, okay, they are strong. Hence, they require a lot of heat energy to be broken. That's the reason why metals that have got high melting point, because there is a strong electrostatic force of attraction. The reason why they have got a high melting point, you say, because of strong electrostatic force of what? Strong of electrostatic force or forces of attraction. The reason why they have got high melting and boiling point, you say, because of the strong electrostatic force of attraction. That's how you are supposed to answer or to understand this question, because of the strong electrostatic force of attraction. Okay, that's supposed to be broken down. So I repeat, explain why metals, they have got high melting and boiling point. The reason why metals have got high melting and boiling point, the electrostatic force of attraction between the positively charged ions and the negatively charged ions are very strong. Hence, they require a lot of heat to be broken down. That's the answer. Number 2, draw the diagram to show the metallic bonding of zinc metal. I said to draw metallic bonding is very simple. You need to draw a table like this, a box, and it's supposed to have a key. So what you have drawn here is supposed to have a what? A key. Why do you put a key? A key, it tells you what you are solving. Number 1, in the metallic bonding lattice, you're supposed to show the free moving electrons, which you say they have got a negatively charged. And what metal do we have? Zinc metal. So you're going to say zinc ion, the charge of zinc, which is a 2 plus. So we're going to say zinc has got 2 positive. This is called zinc ion. Okay, your key. Then what do you put now inside? You're going to say 2 plus for zinc, 2 plus for zinc, free moving electrons, 2 plus for zinc, free moving electrons, 2 plus for zinc, free moving electrons, 2 plus, free moving electrons, 2 plus, just like that. So this is called metallic bonding. So metallic bonding, it is just putting the valency, what you have, what you are losing. So zinc, it has the valence of 2 plus, is the one that you put here, and the free moving what? Electrons. That's what you do. All right. Then as we are concluding, the question is saying, Elena carried out the following experiment in experiment 1, 5 grams of powdered zinc. In experiment 2, 5 grams of granules of zinc were reacted with equal volumes of diluted acid, both of the same concentration, for 15 seconds. The reactions were not yet completed at 15 seconds. In which experiment was the large volume of hydrogen produced? Give a reason for your answer. So because of time, but it's very clear here. They said in experiment 1, here there was powdered zinc, and experiment 2 there was the granules, 5 grams of granules of zinc. So in which experiment was a large volume of hydrogen produced? It was produced during experiment 1 under powdered zinc, because if it is powder, it provides a large surface area. So because it is powder, meaning powder, it will even react more than the granules, because the granules, they need first to melt and everything, but if it is powder, it will react quickly. So the large volume there of hydrogen will be produced under experiment 1. So I'll just put experiment 1, which is the zinc what? Zinc powder. Okay. Now, the first question, the other question is saying, give a reason for your answer. So we're going to say to provide the large surface area for the chemical reaction, to provide the large surface area, because it's powder, it provides the large surface area. What could be the effect of reducing temperature of the acid in the reaction? If you reduce temperature or heat, what will happen? Meaning the reaction, it will be slower, or it will be slow. Okay, reaction will be slow. You say if you reduce the temperature, this is general, you say reaction will be slow. If you reduce the temperature, we say the reaction will be what? Will be slow here. So as we are concluding, and this is the last question, I think. So the following diagram shows the laboratory preparation of gas and its collection. So we have hydrochloric acid there, which is dilute. We have the granules of metal Y, and we have got the gas X. Identify one error in the test in the set of the diagram. So what error can you see there? So we'll talk about nonmetals, and we need to understand this here. That's zinc. This is a metal zinc. Okay. So the funnel, as you can see there, the tap is missing. There is no tap. Number 1. There's no tap. Number 2, as you can see, this funnel here is supposed to have a tap. So you say the tap is what? The tap is missing. Okay. Number 1, that thing, it is not dipped. This funnel and this thing, it is not dipped into the what? Into the reacting substance. It hasn't been dipped. It's supposed to be dipped for the reaction to occur properly. So this is not dipped in here, so there is an error. Okay. Since it's 1 mark, you just say the tap had no funnel. Now, what is gas X? So this is zinc here. This is zinc. Now, if zinc reacts with an acid, it produces the gas called hydrogen gas. Now, how do you tell the test that this is hydrogen gas? So, predict what would be observed or what you can observe. So, there will be no bubbles formed if it is hydrogen gas. There will be no change, there will be no bubbles. So, what is the test for hydrogen gas? What does it do? You know, for oxygen, number 1, it relights the glowing splint, ibushirako. Hydrogen izimya muliro. It burns off the glowing splint with a pop what? With a squeaky pop sound. Okay. Now, with reference to air pollution, compare the use of ethanol and diesel fuels. What is the use of ethanol and diesel? Okay. So, number 1, you're going to say when ethanol burns, number 1, when it burns, it provides less carbon dioxide. And number 1, if there is carbon monoxide in diesel, which is less, so carbon monoxide is found maybe in diesel. If there is incomplete combustion, it will cause effects to the what? To the environment or to the plants. They said in reference to pollution. So meaning, how can these gases cause air pollution? If you burn them in an incomplete combustion, they can cause chemicals or carbon monoxide, which can cause harmful or can cause what? Pollution. And question 9, and we are done. Question 9 was talking about the boiling points. So A has a boiling point of 20 to 60, B has the boiling point of 60 to 110, and C has the boiling point of 110 to 200, and D has the boiling point of 200 to 360. These are showing the fractions of hydrocarbons. This is organic chemistry. Okay, now which fraction contains the longest chain? Give a reason for your answer. Which fraction there has the longest chain? You can even tell the one with the boiling point here. So the fraction D has got the what? The longest chain because of the boiling point. So the boiling point, it is very high. So it has high boiling point, high boiling point. If it has got high boiling point, meaning it has got the long range of what? Chain. Okay, B, decane, which is C10H22, can be cracked to produce hexane C4, C6H14, and other hydrocarbon or T. Deduce the chemical formula of T. So this is general knowledge and it's simple. If this is C10 and H22, then we have removed hexane, which is C4H14, meaning what's remaining for it to be back here to C12, for it to be this, what's remaining here? So we have C6, okay, C6 and H what? What do we have? So this is going to be the alkene, which is going to be C2, I mean. So it's going to be C4, also C4, since this is 6, this is where I've made a mistake, is C6. So this is going to be C4 and H what? C4, we have H8, because this is 22. I didn't get it proper. Okay. Now, how do you draw the structure? That's what we call ethene. So we have the first one, which is ethene. The second one is propene, and this is butene. So how do you draw the structure? We have 4. So to draw the first one has got 2, 3, like this, and 4. So 1, 2, 3, 4. You understand this properly when we start talking about organic chemistry. Here, 1. It's supposed to have 4 chains. So we'll start doing this very soon. This is how you draw the structure, and this is the simplest. Once we start doing this, you enjoy and you know that this is the simplest for sure. Okay, and the last question is saying, would you expect hydrocarbon T to undergo polymerization? Explain your answer. So T, it will undergo polymerization because it is unsaturated. Okay, so it will undergo polymerization because it is unsaturated. It will undergo polymerization because it is unsaturated. All right, distinction students, the paper is done. This is section B of 2024. So the reason why I've taken time is because I was explaining. When you're alone, you make sure you answer it fast and you respond to it according to time. So next time we'll have another live class, maybe to be physics, explaining also another paper and passing through. So this has been recorded. You can watch it anytime. Again, it's on YouTube. All right, so if you have any questions, you can ask in the group and you can leave a comment to this video. Thank you for watching. See you on Monday as we proceed with our class. Make sure follow all the tutorials that we learn in those online classes group. All right, so see you. Have a blessed time. Bye-bye.